All right, welcome, data detectives. Every single data set holds a story. But let's be honest, raw data doesn't just give up its secrets. So today, we're going to equip you with the essential toolkit for any data investigation, descriptive analysis. So go ahead, grab your magnifying glass. It is time to make these numbers talk. So here's our game plan. We're going to start with that big mystery of raw data. Then we'll find our main suspects using measures of the center. After that, we'll see just how scattered the evidence is. We'll pinpoint the location of individual clues. And finally, we'll visualize the entire scene to solve the case. Every investigation kicks off in the exact same place. A scene that's just full of raw, jumbled clues. Looking at a huge table of data can feel pretty overwhelming, right? It's like being handed a puzzle with a million pieces and no picture on the box to guide you. This is where we begin. Staring at a spreadsheet is, well, it's like staring at a sea of numbers. It's just noise. But the story, the insights, those aha moments, they are all hiding there in plain sight. Our job, as detectives, is to use the right tools to bring some order to this chaos and actually uncover the truth. Okay, so our first step is to find the very heart of the data set. We're looking for that one single representative value that can give us a quick summary of the whole picture. These are what we call our measures of central tendency. Our first suspect is the mean, which I'm sure you already know as the good old average. If you have 5 test scores, you just add them all up, divide by 5. It's as simple as that. It's often called the data's center of gravity, that single point where everything balances out just perfectly. Next up, we've got the median. Now, to find this, you have to do one thing first. You have to line up all your data points in order, from smallest to largest. The median is the value that's sitting right smack in the middle. It perfectly splits the data in two. 50% of the clues are below it and 50% are above it. It's the true halfway point of your investigation. And finally, we have the mode. And this one, it's the simplest of them all. It's just the value that shows up most often. So if you're looking at what color car is most popular, or maybe what size t-shirt sells the most, the mode is your go-to detective. Easy peasy. Now, here's where it gets really interesting. The big showdown, mean versus median. The mean, you see, is easily influenced by outliers. A couple of really high or really low numbers can pull it way off center. The median, on the other hand, is robust. So here's the key takeaway. If you're looking at a data set with a few extreme values, like, say, a neighborhood's income where one billionaire lives, the median is going to give you a much more honest picture of what's typical than the mean ever will. Knowing the center is great, but it's only half the story. We also need to know how spread out or how dispersed the data points are. Are they all clustered tightly around that center, or are they scattered all over the place? Hey, think about this for a second. Imagine 2 cities with the exact same average daily temperature. In one city, the temperature is super stable all year. In the other, the summers are absolutely scorching and the winters are freezing cold. Same mean, but you'd pack a very different suitcase, right? That's why we need to measure the spread. Our first tool for this is variance. Now, in short, it calculates the average of the square distances of each data point from the mean. Okay, I know, that sounds a bit complex because of the whole squaring thing, which puts the result in squared units. But don't worry about it. It's a critical stepping stone to our next and much more intuitive tool. And that tool is the standard deviation. It's just the square root of the variance, which brings the measure back into the original units of our data, making it so much easier to understand. A low standard deviation means the data is all tightly clustered around the mean. A high standard deviation means it's really spread out. Simple as that. Okay, so we've found the center, we've measured the overall spread. Now it's time to zoom in. How do we figure out where one specific clue stands in relation to all the others? Well, we do this by slicing up our ordered data. Percentiles, they cut the data into 100 little pieces. So if your test score is in the 90th percentile, that just means you did better than 90% of the people who took the test. Quartiles are just specific, really useful percentiles. Q1 is the 25th percentile, Q3 is the 75th, and hey, look who's back. Q2, the 50th percentile, is none other than our old friend, the median. And quartiles lead us directly to one of the most powerful tools in our entire kit, the box plot. This single chart is an absolute masterpiece of descriptive analysis. It visualizes the 5-number summary, the minimum, Q1, the median, Q3, and the maximum. It immediately shows you the center and the spread, and See those little dots outside the whiskers? Those are potential outliers that we definitely need to investigate. So we've gathered all our numerical summaries. Now it's time for the final and often most powerful step in our investigation: visualizing the clues. It's time to put everything up on the evidence board and actually see the patterns emerge. The histogram is a fundamental tool. It groups numbers into ranges or bins, and the height of the bars shows how many data points fall into each range. This instantly reveals the shape of your data. Is it a nice symmetric bell curve, or is it skewed way over to one side? This is basically the data's fingerprint. Now, don't confuse a histogram with its cousin, the bar chart. Bar charts are not for continuous data. They are for comparing distinct categories. You know, how many sales did product A have versus product B? A bar chart makes that comparison instantly clear. It's simple, it's direct, and it's incredibly powerful. But what if you suspect two different clues might be connected? Well, that's when you bring in the scatter plot. You just plot one variable on the x-axis and another on the y-axis. Do the points form a line, a curve, or just a random cloud? This is exactly how detectives look for connections, for relationships, for correlation in the data. And you should never, ever underestimate the power of a good chart. As this quote reminds us, visualizing your findings isn't just about making things look pretty. It's about communicating your conclusions with real clarity and impact. A great chart can make your entire case for you. So, we have been through a lot. Let's take a step back and organize our new toolkit, recapping the essential instruments that every single data detective needs to have. And here it is. To find the center, you've got the mean, median, and mode. To understand the spread, you've got variance and standard deviation. To locate a specific point, you use quartiles and percentiles. And to bring it all home, you have a whole suite of powerful visualizations like histograms and box plots. This is your core detective kit. Master these, and trust me, no dataset can hide its secrets for very long. So you now have the fundamental tools to take any messy, mysterious dataset and start uncovering its secrets. You can find its center, you can measure its spread, and you can visualize its patterns. So really, the only question left is, with this toolkit now in your hand, what mysteries are you going to solve first?